Question 1. For example, Example 1. If a and b are integers, is a plus b equal to an odd number? Condition 1. A minus b is equal to an odd number. Condition 2. B is equal to an even number. Solution. Now we will solve this DS question using the algorithm of the variable approach. Algorithm of the variable approach flowchart. The most difficult questions are key questions, which deal with integers, statistics, probability, inequality, and absolute value. Answering this question correctly and efficiently is key to attaining a score of 50 to 51. These questions are usually related to CMT 3 and 4, so you should double-check the question with these CMTs after applying the variable approach. Now, we're going to solve the question based on the flowchart above. Remember this carefully. If you do not want to solve, or it has taken you more than 5 minutes, choose C. If you are solving the question, the answer can be C or E as per the variable approach. There can be 2 cases if you get an answer C. The question could be a key question, a case which will require you to apply CMT 3 or CMT 4 A or B. Or it may not be a key question, for which the end answer will continue to be C. Let's apply the 3 steps suggested previously. Follow the first step of the variable approach by modifying and rechecking the original condition and the question. We have to find out whether a plus b is odd if a and b are integers. Let's modify the original condition and apply CMT 1, which says that we should get a unique answer as yes or no for the condition to be sufficient. We have learned that odd plus odd or even plus even is even, while odd plus even is odd. Also, this is an integer question, and therefore we will have to apply CMTs 3 and 4 A or B. Follow the second and the third steps. Applying the variable approach. Match the number of variables in equations in condition 1 and condition 2, same as original conditions. We get 2 variables in the original condition, so we require 2 equations. As each condition can give us 1 equation each, the answer is likely to be C. Recall the 3 principles and choose C as the most likely answer. Let's take a look at both conditions together. Then we get A minus B as odd and B as even. So, A minus even equals odd. That is, A equals odd plus even, which equals odd. Therefore, the sum A plus B is equal to even plus odd, which equals odd. And C should be the answer by CMT 1, which means that the answer must be in terms of a unique yes or no. However, this is an integer question, and an easy C as an answer requires us to look for 4A. This means we need to look at the relationship between VA and CMT3 and CMT4 A or B before choosing our final answer. So, we will have to consider each condition separately. Condition 1 tells us that A minus B is odd. Let's look at both cases of B and see the effect on A. If B is odd, A minus odd equals odd, or A equals odd plus odd. That is, A is even. The sum in this case will be A plus B equals even plus odd, which equals odd. The second case will be when B is even. Then A minus even equals odd, or A equals odd plus even. That is, A equals odd. Again, the sum A plus B equals odd plus even, which equals odd. In both cases, we get a unique answer, yes. So this condition is sufficient by CMT 1, which means that the answer must be in terms of a unique yes or no. Condition 2 tells us that B is even. We cannot say anything about the sum a plus b, as we do not know the value of a. If a equals 1, a plus b equals 1 plus even, which equals odd? Yes. But if a equals 2, a plus b equals 2 plus even, which equals even? No. We get two different answers, both yes and no, and the condition is not sufficient by CMT1, which means that you get both yes and no as an answer. It is not sufficient. This is a demonstration of the process from the variable approach to CMT4A using the flowchart. Carefully remember the process. Remember that if the question has both C and A as its answer, then A is the answer rather than C by the definition of DS question. Condition 1 alone is sufficient. So, A is the correct answer. Answer A. The question below is different. It shows the process of finding E as the answer when there are two variables in the original condition. Pay attention.